In order to replace the system of forces acting on the sling by an equivalent resultant force and a couple moment at point O, we can start by first figuring out the resultant force. Since the system is in 3D, it will be easier to calculate them by representing the force in the Cartesian form. So to start, our force F1 is acting vertically upward. So it only has the Z component, which is represented as 600K. Next, I have a force of F2 that is making an angle of 45 along the XY axis. So taking the cos 45 function will project the force along our xy plane. Next, this line is making an angle of 30 degrees with respect to the x-axis. So taking the cos function again is going to project the 500 cos 45 force component times cos of 30 along the x direction. Similarly, if I take the sine 30 function, it is going to project our 500 cos 45 along the y direction. Now, once we have that, let's go ahead and represent our I and j component. So F2 will be equals to 500 cos 45 cos 30, and since it is acting towards the positive x direction, that's why it is taken as positive. Similarly, our 500 cos 45 sine 30 is pointing towards the positive y direction, so that's why that is also taken as positive. Finally, we have to figure out the z component of force F2. Since the force F 500 is making an angle of 45 degrees with respect to the xy plane. If we take the sine 45 function, it's going to project it along the z direction. Simplifying, we get our F2 force as 306.2 I plus 176.8 J and our 353.6 K. Next, let's go ahead and resolve our force F3 having a magnitude of 400 pound. Here we are giving the angles this force is making with respect to the x, y, and z axis. So we can utilize our direction cosine to figure out the x, y, and z component. So taking 400 cos of 60 will project the component of the force along the x direction, plus 400 cos 120 will project it along the y direction, and finally 400 cos 45 will project it along the z direction. Now simplifying, we get our F3 as 200i minus 200j plus 282.8k. Now, once we have all the forces represented in the Cartesian form, let's go ahead and add them all together. Now, once we are adding, we add all the I components together to get our I component resultant, that is coming as 506.2 I. Next, we add all the j components together. Here, F2 and F3 has the j component. Adding them together, we get the value of negative 23.2 j. And finally, we have k component for all the three forces. Adding them together, we get our value of 1236k. Now, once we have our resultant force, let's go ahead and target the couple moment. Now, since we are calculating the couple moment at point O, so the resultant moment will be the sum of moment of all the three forces with respect to point O. So let's start with our force F1. Now, for the moment arm, it is a distance from the point across which we are calculating the moment towards the line of action of the force. So our moment can be calculated by r cross f, where r is the position vector. In this case, for force F1, it is 1I, as the distance of the crate from point O to the line of action of the force is equals to 1 times the force, that is 600k. Next, we can go ahead and figure out the position vector of force F2, again measuring from point O heading towards the force F2 line of action. That distance is negative 0.25j. The negative sign is indicating it is going in the negative y direction. Taking a cross product with F2 will give us the moment this force is going to create about point O. Finally, the moment arm of force F3 can be calculated in a similar fashion, that is from point O heading towards the line of action of F3. This distance is 0.25 j. This time it is positive since it is heading towards the positive y direction. So taking the cross product of the position vector 0.25 with the force F3, that is 200I minus 200J plus 282.8 K, will give us the moment the force F3 makes about our point O. Now let's go ahead and take the cross product. So the first term is I cross k. That will give us the negative j term. So that's why the very first term I have is negative 600j. Next I have j cross I. This is going to give the negative k term. Since I have a negative sign with 0.25, that's why I have a positive term. Next, j cross j is equals to 0, whereas j cross k is equals to I. That's why we have negative 88.4i. Similarly, we can repeat that for our moment m3. Here, j cross I is also equals to negative k. J cross j is 0, whereas j cross k term is going to give us the I component. Now, once we have everything, let's add them together. So our resultant value of moment is coming as negative 17.7i minus 600j and plus 26.5k Newton meters.